In this presentation, today we will discuss about introduction of the thermodynamics. What is thermodynamics? Which kind of equilibrium we can explain this thermodynamics? And what is isothermal process? What is adiabatic process, etc. We will discuss in this concept. What is thermodynamics? Thermodynamics is a branch of physics which deals the relation between heat energy and mechanical energy and vice versa. It means that by using thermodynamics, we can convert heat energy into the mechanical energy or mechanical energy into heat energy. So to understand the thermodynamics, initially we want to know what is system and what is surroundings. Here system is nothing but it is a matter surrounded by some closed surface. System is a matter, it is surrounded by some closed surface. So in this system, most probably in thermodynamics, system is nothing but is a gas containing cylinder with a movable piston. By using this piston, the gas can be expanded or the gas may be compressed. So this is taken as a system in thermodynamics. So this is one of the example. This is one of the example of the system. This is the cylinder. It is gas is filled with the piston. So when the piston is sent downwards, it is contracted. If this piston moved upwards, it is expanded. So this is called system. In most probably in thermodynamics, we may take as ideal gas as the working substance in this system. And what is surroundings? Of course, this is also system. This is open system. The cup of coffee is taken. There is no cap. So the heat energy in the coffee or maybe tea, it will go into the surroundings. It will go into the surroundings. So this is called open system because the heat energy is transferring from system into the surroundings. This is called closed system. Of course, there is a cap on the cup. So it is closed. So there is some possibility to transfer of heat energy due to the conduction or maybe convection by the cap. And this is isolated system. Maybe this is called thermos flask or tea flask. It is totally closed. So there is no possibility to come heat energy is entered into the surroundings. So this is called isolated system. So what is surroundings? Of course, the surroundings are outside the system and which influence the behavior of the system. Surroundings is outside the system and which influence the behavior of the system. So for example, you see here, the surrounding of this open system is called surroundings. So then this heat energy is taken by the surroundings. Here also there is a place which is around the system is called surroundings. Here also this is the system. The place around this area is also called surroundings. So here we will discuss some equilibrium positions. What is mechanical equilibrium? What is chemical equilibrium? What is thermal equilibrium? And later, what is thermodynamic equilibrium? So mechanical equilibrium is nothing but there is no unbalanced force between system and surroundings is called mechanical equilibrium. So there is no unbalanced force is nothing but the net force acting on the system is zero. The net force acting on the system is zero. You may see here the one of the example. There is a table. On a table, the book is there or maybe any object is there. If any object is kept on the table, there is gravitational force mg downwards. So we know when the object is kept on the table, some normal force acting upwards. We know if this object is in equilibrium position, the normal force N, which is equal to mg. According to the Newton's third law of motion, that is action is equal to minus reaction. So in which the resultant force on this object is zero. So this is in mechanical equilibrium. This is in mechanical equilibrium. What is thermal equilibrium? Thermal is nothing but related to temperature. A system in which all parts of the body having equal temperature. A system in which all parts of the body having equal temperature and the sun with the surroundings, then the system is in thermal equilibrium. For example, in our laboratory, if the temperature at all points of the room is constant, that is in all directions, the temperature is the same, then the room is in thermal equilibrium. So how can we say? This is one of the example we can say thermal equilibrium. So initially there is two objects. This blue color object is at 0 degrees Celsius and this pink color object is at 100 degrees Celsius. If those two objects are contact each other, after some time, those two objects are at 50 degrees Celsius each. So the two objects is at same temperature. So these two objects is in thermal equilibrium. And here also one more example we may see. This is at coldest place of this point. This is hot place. Of course, these two bodies are connected with the some in conductor. Then the heat will transfer from higher temperature region into the lower temperature region until the temperatures are equal. So after temperatures equal, this system is also in thermal equilibrium. What is chemical equilibrium? So chemical equilibrium says about the concentration of molecules or molecular density. So a system in which chemical composition is the same throughout the system, such system is in chemical equilibrium. The system in which chemical composition is the same throughout it is called chemical equilibrium. One example we may see here. This is the nitrous oxide. This is also nitrogen dioxide. This chemical reaction between them is stopped when toward the material is at same distribution of molecules. This is one of the example of chemical equilibrium. And what is thermodynamic equilibrium? Any system which is in mechanical equilibrium, thermal equilibrium, and chemical equilibrium at a time. Chemical equilibrium at a time. Then such a system is in thermodynamic equilibrium. So now actually we are going to the thermodynamics. Actually there are different laws we have regarding thermodynamics. The first law is the zeroth law of thermodynamics, and the second law, first law of thermodynamics, and of course second law of thermodynamics, and of course third law of thermodynamics. Of course, in this undergraduate level, we will discuss only up to second law of thermodynamics. Initially, we will discuss about what is zeroth law of thermodynamics. If two objects A and B individually in thermal equilibrium with a third object C, there is two objects we have taken. This is object A. This is object B. Both are at different temperatures. These two temperatures are connected with C. We know after some time A and C are thermally contacted. So the temperatures of the A and C are equal. So that A and C is in thermal equilibrium. At the same time, B and C are at different temperatures due to the heat transfer. After some time, B and C are in same temperature. So B and C is in thermal equilibrium. Of course, after some time, A and B also in the same temperature, that is called in thermal equilibrium. So this is called zeroth law of thermodynamics. If A and B objects are in thermal equilibrium with the third object C, then A and B also in thermal equilibrium. This is called zeroth law of thermodynamics. The importance of this zeroth law of thermodynamics is it defines the temperature. It defines the temperature. Here, what is temperature? A physical quantity which says those two bodies are in equilibrium is called temperature. If these two bodies in equilibrium is nothing but those temperatures are equal. So such physical quantity is called temperature. So if two bodies are in thermal equilibrium because of its temperature. What is first law of thermodynamics? Of course, first law of thermodynamics obey the conservation of energy. It says that when the heat energy is supplied to the system, when some heat energy is supplied to the system, this quantity of some of the energy is used to do some external work, and the remaining energy is used for increasing its internal energy, so that the total heat energy supplied to the system is equal to sum of the external work and increase in internal energy of the system. So this is called first law of thermodynamics. For example, in our house, in our daily life, some water is kept on the stove. Initially, when we are giving heat, the total heat energy supplied by stove is absorbed by the water and its temperature increases. It is nothing but its internal energy increases. After some time, whose temperature is greater than 100 degrees Celsius, the water is converted into vapor. That vapor push the lid. It is pushing the lid is nothing but some work is done by the vapor on the lid. So that work is taken from the heat energy. So the heat energy given by the stove, which is equal to an amount of internal energy increase of the system plus work done by the vapor. So this is also one of the example of the first law of thermodynamics. So mathematically, how can we write? If a dq is the amount of heat given to the system, that is equal to du is the internal energy, increase in internal energy, and dw is the work done by the system. That is dq is equal to du plus dw is the first law of thermodynamics. Of course, where dq is the amount of heat energy given to the system, du is the change in internal energy of the system, and dw is the amount of work done by the system. Here it obeys the conservation of energy because dq is heat energy, that is equal to du is internal energy, and dw is equal to work done, that is also form of energy. So it obeys conservation of energy. So we have two process we may observe in this thermodynamics. One is isothermal process and the second one is adiabatic process. Of course, there is more processes are there, isochoric process and isobaric process also. Initially, we will discuss about isothermal process and adiabatic process. What is isothermal process? A process that is in thermodynamic system undergoes a physical change in which the temperature remains constant. It is nothing but the temperature of the system is not changed. Such process is called isothermal process. It is nothing but the system may be received from the surroundings or may be given to the surroundings of heat, so that it's mainly it maintains the constant temperature. It maintains the constant temperature. This process is called isothermal process. So thermodynamic system which undergoes a physical change in which temperature remains constant, such process is called isothermal process. So in this isothermal process, temperature remains constant, so can be written as dT is equal to 0. dT is nothing but change in temperature is 0. Of course, not only that, due to the temperature remains constant, the internal energy of the system is also constant, so that internal energy remains constant in isothermal process. So we may write dT is equal to 0 and du is equal to 0 in isothermal process. So isothermal process obeys Boyle's law. We know ideal gas equation PV is equal to RT. PV is equal to RT, in where you know R is universal gas constant, T is the temperature. Of course, in this isothermal process, T is also constant. So that R and T constant, therefore only PV is equal to constant. We know PV is equal to constant is the Boyle's law. So that isothermal process obey the Boyle's law. So that PV is equal to constant is the equation of isothermal process. And now we will discuss what is adiabatic process. Of course, a thermodynamic system in which no exchange of heat takes place between system and surroundings. Such process is called an adiabatic process. So, for example, what we have taken some cylinder and there is a piston. If you press the piston, then what happens? Then the temperature of the system increases, even though if the surrounding is made by the adiabatic, that is the insulating material, there is no heat energy will go to the surroundings. So there is no heat transfer between system and surroundings. Such process is called adiabatic process. So in which a process in which no exchange of heat takes place between system and surroundings, such process is called an adiabatic process. Of course, in adiabatic process, heat energy, not only that entropy, a thermal quantity, that is entropy also remains constant. So that we may take as dq is equal to 0 and ds is equal to 0. That is a dq, change in heat energy is 0, and the change in entropy, that is a ds is also 0. Of course, the equation of the adiabatic process is PV power gamma is equal to constant. P we know that is the pressure of the system, V is the volume, and gamma is the ratio between specific heats at a constant pressure and constant volume. That is Cp is equal to Cv. So that is about the equation of the adiabatic process. Thank you.